Hello dear students, now we are going to start transistor. So transistor means trans plus resistor means a device which transform resistance from one level to another level, that is the transistor. And it is made up of semiconductor devices, and in semiconductor it is made up of extrinsic semiconductor devices. It is of two types. One is the bipolar junction transistor, in which there is a flow of current because of minority as well as majority both charge carrier. And the second one is the field effect transistor. It is known as unipolar, and there is a flow of current due to one charge carrier only. So let us come to start about bipolar junction transistor. So bipolar junction transistor, it is of two types. It is of two types, maybe PNP type or maybe NPN type. Means if one P layer, one N layer that is joined, then again one N layer and one P layer is joined. So there is a formation of PNP and PNP transistor, and it is having three layer. One is the P layer, second one is the N layer, third one is the P layer, and it is having three terminal. One is the emitter, second one is the collector, and the third one is the base. And it is having two junction. One is this PN junction, second one is this NP junction. So in summary, what we say about transistor is having three layer. Three terminal and two junction device. So transistor is a device which have a three layer and three terminals and two junction. It may be NPN type. If it is NPN type, so there is a one N layer, there is one P layer, again there is a one N layer, and three terminals, emitter, collector and base, and two junction. One is this NP junction, second one is the PNP junction. E stand for emitter, B stand for base, C stand for collector. So up to this stage, what information we obtain from here, that transistor is of two types. One is the NPN transistor, second one is the PNP transistor, and it is having three layer, three terminal and two junction, right? But doping pattern in different layer are different. Doping pattern in different layer are different. So let us come to discuss about doping pattern. In we know that to increase the conductivity in intrinsic semiconductor, doping is done. So out of these three layer, highest doping is done in the emitter, least doping done in the base, and collector is moderately doped. So it means we know that if we increase the doping level, so conductivity of that material is going to increase. So out of these, emitter is having highest doping, it means emitter is having highest conductivity or least resistivity. Least resistance it has, means it is very good conductor of electricity, and base is having least doped, it means it will offer very high resistance, means very less current will flow through base, and a collector is moderately doped, so the current flowing through collector will be in between base to emitter. So from this one information we conclude that emitter is highly doped, collector is moderately doped, base is lightly doped. So because of this doping pattern, out of these, emitter is having highest current, base is having least current, emitter is very good conductor, and base is least conductor. It means if we compare in relation in terms of resistance, so base is having highest resistance, then there is a resistance of collector, then there is a resistance of emitter. And if we talk about current relation, so because of this doping pattern, emitter is having highest current, collector is having moderate current, while base is having least current. So remember, these relations are very helpful for any kind of competitive examination. Now let us erase it. So up to this stage, what information we obtain, that a transistor is of two types, maybe NPN type or PNP type, and it is having two junction, three layer, and the three terminal device, out of which doping of emitter is highest, doping of base is least, while collector is moderately doped. Now let us come to operation of transistor. So in this, input junction is forward bias, means this emitter, base, and collector. Let us take highlighter. Emitter to base, it is connected with the plus of the battery. It means emitter to base junction is forward biased, in which P region is connected with the plus of the battery, while N region is connected with the minus of the battery. And base to collector junction is reverse biased. Reverse bias means now output side P layer is connected with the minus of the battery, while N layer is connected with the plus of the battery. And we know that based on biasing pattern, their width of depletion layer is going to change. If any PN junction is forward biased, if any PN junction, let us draw PN. If it is made forward biased, so in this case, the width of depletion region is going to reduce. This is depletion region, and because of forward biasing, the width of depletion region is going to reduce. The main point is that, see, P is connected with the plus of the battery. In the P region there is a holes, means positive charge or majority charge, so same charge are going to repel, so they will produce a force. Similarly, in negative side, N region is connected with the negative terminal of the battery, it means negative charge also being repelled. So because of this repulsion, the width of depletion region is going to reduce. And we know that if this voltage, if this forward bias voltage is more than VB, that is forward breakover voltage, it is zero point 0.7 volt for silicon and 0.3 volt for the germanium. So there is a start of conduction. Whatever majority charge carrier is there, that will surpass across this junction. So it means there is a flow of diffusion current. This is diffusion current. And if any PN junction is reverse biased, let us come to draw about the, let us erase it. If any PN junction that is reverse biased, means P is connected with negative terminal of the battery, while N is connected with the plus of the battery. So we know that because of this pattern, the width of depletion region that is going to increase. This is width of depletion region. So because of this pattern, uh, to break this depletion region width, there is a required to apply very high voltage, and so there is no current until reverse breakdown occurs, and this only small current that will flow because of minority charge carrier. So because here there will be electrons as a minority charge carrier, here there will be holes as a minority charge carrier. So there is a flow of very small current because of minority charge carrier, and that current is known as leakage current. That current is known as leakage current. So that is a current which is flowing in this main diagram. That is this one, this current. That is because this region, this junction, this PN junction, width of this PN junction is small, while width of this NP junction is large. So this NP junction is reverse biased, while this PN junction is forward biased. Okay, so if this VEE voltage is just slightly more than 0.7 volts, so there is a complete start of conduction because of majority charge carrier. So there is a diffusion current, and with the VCC voltage, the junction NP that is reverse biased, so there is a very small current, that is leakage current, which is flowing because of minority charge carrier. And a question arises in mind, whatever current that is going to pass from the P layer, let us erase it first. A question that arises in mind, see the total majority current, if it is passing from the P to N, a question arises in mind whether it will pass through towards the C side or it will pass toward the base side. So we know that base is lightly doped. So because of this lightly doping, resistance of this base region, the resistance of this base region are very high. So we know that current always follow minimum impedance path. So out of these, a fraction of current will pass through towards the base side, and the remaining current will pass towards the collected side, just like here minority charge carrier are passing. Okay, now let us erase the entire process. So up to this stage, what information we obtain means whenever PN junction is forward bias, So after zero point 0.7 volt, if the device is made up of silicon, so there is a flow of current, there is a start of conduction, and if the PN junction is reverse biased, so there is a only leakage current. And here there is a two PN junction. So input side, the device, because of this biasing pattern, so input side it is behaving like a diode, while output side it is reverse biased. So there are two current at the output side, one that is the because of minority charge carrier, and second is due to majority charge carrier. So IC collector current is having two component. One is the majority charge carrier of collector current, while second is the minority charge carrier of the collector current. Okay, let us come to next slide. So see, if we apply KCL, if we apply KCL here, so we know that as per statement of Kirchhoff current law, as per statement of Kirchhoff current law, algebraic sum of all the current meeting at a junction is equal to 0. Means see, IE is the incoming current, while IC and IB they are the outgoing current. It means IE will be equal to IC plus IB. IE is equal to IC plus IB. And collector current will be sum of two current. Collector, I repeat again, collector current will be sum of two current. One is the collector current due to minority charge carriers, while second is the collector current due to majority charge carriers. So it means IC is equal to IC majority plus IC minority. So if we talk about working of NPN transistor, because we have till now we have described about the PNP transistor. So and working of NPN transistor is same just like PNP transistor, except in case of NPN transistor there is a flow of majority charge carrier that are electrons, while in case of PNP transistor there is a flow of majority charge carrier that is holes. See, current due to majority charge carrier that is holes, and in case of NPN transistor the current due to majority charge carriers that is the electrons. Rest working are same, biasing pattern are same. Emitter to base junction forward biased, while collector to base junction reverse biased. So now come to configuration, different configuration of transistor. So one question arise in mind, what is the need of configuration and why we do this? So answer for this question is that we know that a transistor, it is a three terminal device. Transistor is a three terminal device, emitter base collector. But if we use this device in different applications like as amplifier or like switch, so obviously we need to use it like a two-port network. We need to use it like a two-port network. So in two-port network, how many terminals are needed? Four terminals. This is symbol of NPN transistor and it is a three terminal. But if we are going to use this device in two-port network, two port network. In that case, we require two input terminal and two output terminal. But with the transistor, problem is that it is having three terminal only. So how to generate fourth one? Simple answer is that to make one terminal as a common, means that one terminal if we make common both input side as well as output side, so there is a formation of two port network. So in this case, now in this case, okay, so if we use base as a common term, both side from input to output, if we let us make both base as a common both from the input side as well as the output side, so now this become common base configuration. Okay, similarly we can make this for the same for the NPN also. This one. So it means now here base become common to input side as well as output side. We will feed input signal at this side and we will get output signal from that side. One question arise in students in their mind, that how to recognize which one is the NPN, which one is the PNP from the symbol. So remember, just see the direction of current in the ammeter. If it is exit from the emitter, so this is the NPN transistor, and if it is coming towards the emitter, means this one, so it is the PNP transistor. So by this notation we can identify it. Okay, so anyway, we were discussing about common base configuration. It means base is made common from input to output side, and we know that to perform this task, we know that to make this device to perform like either amplifier or switch, we need biasing. And I hope from the previous classes, that is the from basic electronics, we have already read that if both junction, means base to emitter junction and collector to base junction, if we made forward biased, so it will be have like on switch. If we made both junction reverse biased, it will be have like off switch, means open circuit. And if input junction is forward biased while output junction is reverse biased, so it will be have like amplifier. This information we I think we are familiar with in from the previous classes. Okay, so see, as per this connection, emitter to base junction, that is the forward biased, collector to base junction, that is the it is reverse biased. It means now it is connected in terms of amplifying mode. So if we made connection in such a pattern that emitter to base junction is forward bias, it means there is a flow of current because of holes as a majority charge carrier from P to N, and after passing from this junction, a very few current that will pass towards the base side and the rest current will pass towards the collector side. Apart from this, there will be a small amount of minority charge carrier current. Okay, that but amount of this is very small as compared with the majority charge carrier, because if the current in the majority charge carrier, if it is in the range of milliampere, so current flowing because of minority charge carrier, that will be either in the range of microampere and nanoampere. That is very small. So let us come to find the input characteristic. Input characteristic means characteristic between input voltage versus input current. So input voltage is emitter to base, this one, emitter to base, and input current is the emitter current. So let us erase first, then we move towards next slide. So till now, one information we obtain in this slide, that why we do different configuration to use it like a two port network. Once if we made emitter as a common, so this become common emitter configuration, means which will be common to both from input as well as output side. If we made collector as a common, so that become common collector configuration. If we made base as a common from input to output side, so this become common base configuration. So let us come to characteristic for this. So as we know that input junction in this case is forward biased. So it is simply a PN junction. It is simply a PN junction, that is nothing but it is a diode which is made forward biased. PN junction, that is simply a diode. PN junction, that is simply a diode which is made forward bias. So a question arises in mind, what will be its characteristic input voltage versus input current? So simple answer is that whatever characteristic of diode in forward biased, whatever characteristic in diode that is in forward biased, that will be the characteristic at the input side. This is base to emitter voltage. What will be characteristic? Just like a diode, means we know that after zero point 0.7 volt there is a conduction in the diode, and before that there is only leakage current. Before that there is only leakage current. So what will be characteristic? So characteristic will be like this. This is only even it is showing this much amount, in practical circuit it is almost negligible. It is almost negligible. So that will be, if we redraw it, if we redraw this curve, so this become, it will follow like this, because the before on state there is a very small current that is in the range of either micro ampere or nano ampere, and this emitter current is in the range of milliampere. And once we are going to increase the collector to base voltage, once we are going to increase the output side voltage, so emitter current is continuously going to accelerate based on that pattern. See, first curve when the collector to base voltage is 1 volt, second curve when the collector to base voltage is 10 volt, third curve when collector to base voltage is 20 volt, and so on. Now come to its output characteristic. So what will be its output characteristic? That is simply it is drawn between output voltage versus output current for the different input current. I repeat again, what will be the output characteristic? Output characteristic will be between input output voltage versus output current for the different input current. Come to this one. So see, when see this is output voltage, that is collector to base voltage, vertical axis is the output current, that is the collector current, which is in the milliampere. And once there is no voltage at the input side, means if there is no voltage at the input side, means there is no current from the input side, so during this there is only leakage current, that will flow because of minority charge carrier, and this is the case of cutoff region. And if we increase the input voltage from base to emitter from the input side, so there is an increment in input current, that is emitter current, and accordingly with the relation IE is equal to IC, that is collector current, plus IB base current. If there is an increment in emitter current, accordingly there is an increment in collector current. Okay, so for different increase in emitter current by changing the base to emitter voltage, accordingly there is an increment in collector current. So this is family of collector current versus collector to base voltage curve for different base to emitter voltage, means different emitter current. So this region is the active region. In this region, if we just reverse collector to base voltage, so it means the second means output PN junction is going to forward bias from the reverse bias, so the device will switch from the active region to saturation region. Okay, and now this is the case where both junction are reverse bias, means cutoff region. So that's all for today's for this lecture. Thank you all of you.